Aloha, I'm Kirsten Baumgart-Turner, and this is Sustainable Hawaii at thinktechhawaii.com, streaming live educational and civic engagement on the internet and Oceanic Channel 16. The past 2 weeks, this show has examined the problem of solid waste and food waste in our island state, and we've discussed ways to first reduce it and second, manage it sustainably. Today, we'll discuss the growing problem of human waste, which is delicately referred to as wastewater, and some cutting-edge ways that we can sustainably eliminate their most noxious impacts, both puns intended. On its website, the Hawaii State Department of Health tells us, quote, cesspools are substandard systems. They don't treat wastewater, they merely dispose of it. Cesspools concentrate the wastewater in one location, often in direct contact with groundwater that flows into drinking water wells, streams, and the ocean, harming public health and the environment, including beaches and coral reefs, unquote. Yet there are 90,000 cesspools in Hawaii that release approximately 55 million gallons of untreated sewage into the ground each day, and about 800 new cesspools are approved for construction each year. Indeed, Hawaii is the only state in the U.S. that still allows construction of new cesspools. Meanwhile, every day the city and county of Honolulu collects in its system about 100 million gallons of wastewater from the toilets, sinks, and drains on Oahu. The wastewater is delivered through a system of 2,100 miles of pipeline to 9 wastewater treatment plants, which are spread around the island. And all this takes a great deal of energy. The city has experienced numerous overflows that have caused millions of gallons of untreated sewage to be discharged into local waters. Only recently is some of that wastewater treated to secondary and tertiary levels. That wastewater is then discharged back into the environment by ways of the ocean, reservoirs, or underground injection wells. In a few cases, it is recycled and reused for irrigation and industrial purposes. Dennis Furukawa, founder and CEO of Real Green Power, is here today to discuss the case for recycling and reusing our kukai, I mean wastewater, and the sludge it leaves behind. Welcome, Dennis. Thank you so much for coming to talk to us about this sometimes delicate subject.
Well, thank you, Kirsten, for having me.
Now tell me, what brought an architect to Hawaii to work on our wastewater problems?
I'm deeply motivated by protecting our water resources, and so coming from California, where water has been high on the agenda to both protect and to utilize as most efficiently as a resource. The motivation really is that water is life, and it is connected very deeply with energy as well. So in California, you have hydro water production, and of course water is used in thermal energy production. So it is deeply important, I think, to everybody to concentrate on protecting that as a resource.
I love that you say water is life, kawai ola, in the Hawaiian perspective. So it sounds like you've really engaged and embraced the Hawaiian values for water in Hawaii, and certainly the lack thereof in California motivates you to help us save it here in Hawaii. Now, you're an architect by design. I'm afraid I'm full of puns today. Tell me a little bit about your background. I know you went to Berkeley and got an architecture degree. What kind of projects were you working on?
I've done a wide range of things, from marinas, public housing, high-rises, restaurants, hospitality, a huge number of things. But I started gravitating towards sustainable architecture. So construction methods where or trying to achieve zero waste. So construction waste is about 30 to 40% of actually all the materials that go into a house or any structure.
Really?
It's a huge amount of waste. So trying to create more more sustainable ways of building. But what is the primary driver was that in order to develop property, land, you need to have hookups for water and sewer. And when you're in remote locations, those can be real challenges. And they are the linchpin in a lot of cases for whether or not you can develop a piece of property or not.
So when you were in the middle of developing a lot of variety of projects, you saw an opportunity for maybe providing solutions through architecture from a sustainable perspective?
The work actually that goes into getting the approvals to develop a piece of property or a particular project, so much of the front-end work actually was getting the permits for wastewater disposal or getting a water meter. So I early on, 15 years ago, began putting together strategies to recycle water and to produce energy on site, to minimize essentially the reliance on developing infrastructure, which in general most people don't want to pay for.
And then it creates waste, which you wanted to avoid.
Indeed, yeah, it does.
So you created Real Green Power. What kinds of products and services do you provide?
Well, Real Green Power was formed to take wastewater as a resource rather than a problem. There are qualities to wastewater, particularly its fermentability, and that fermentability is a factor in producing methane. And methane is a combustion fuel, it's natural gas. And so by turning those pollutants, which are fermentable, into natural gas, you do two things. You clean the water and make energy at the same time.
I don't think most people would see qualities in wastewater. So that's interesting, because you see it then as those qualities are a resource that can be used to then, as you said, clean the water, but also what would bring you to the realization that this could be a solution beyond the methane, because there's other qualities that you've looked at and are utilizing for Real Green Power?
Well, you had mentioned that the city disposes of 100 million gallons of wastewater every day. I think the statistic was 60,000 pounds of nitrogen and 6,000 pounds of phosphorus are lost in that 100 million gallons. And nitrogen and phosphorus are the key building blocks for proteins, and those are utilized by plants to build the plant matter, which is the building blocks of the food that we eat.
And that's one reason why it's a problem if they're just dumped into the ocean.
Absolutely.
Because it's like an invasive species. It creates algal blooms and other noxious products, right, that weed out or push out our natives and tend to choke out our coral reefs.
Well, more importantly, we import fertilizers here in Hawaii at a very large scale. And especially for phosphorus, it's actually a limited resource on land, which in the foreseeable future, the deposits in the United States are vulnerable to depletion. I think the numbers were within 15 to 20 years. So our reliance on phosphorus will then be one of those things that we need to import. And Hawaii is like way down the chain when it comes to the global supply chain. So while we import so much in the way of food, that contains the nitrogen and the phosphorus that are useful in growing the food, why don't we just actually mine our resources from the waste that we produce.
So just to break that down, sorry, okay, so you have the opportunity to make the water cleaner by using the biology, right? That's breaking down the negative elements in the water, but you also have the opportunity to capture the phosphates and to capture the nitrogen, and that allows you to use it again as a fertilizer resource. What other positives come from recycling the wastewater?
Well, it's an opportunity for jobs. So that's actually very central, because one of the big limiting factors here in terms of whether or not you can farm is not so much access to land, but it's actually more access to water. So we've all been familiar with that. There have been all kinds of legal battles over the history of Hawaii centered around the taking of water and moving it from one side of the island to the other.
As a matter of fact, we had a whole show on that subject. So Bill, no, I'm going to forget his name, but Bill Tam, who's the former deputy at DLNR in charge of wastewater, did a great entire show for us on that issue.
Right. So our strategy is to take wastewater, clean out the fermentables, free up the nitrogens and the phosphates, and use that water directly for irrigating productive lands. So you can create farming opportunities in places where otherwise they would not occur, and do it sustainably, where you don't need to import, fertilizers, or you reduce your reliance on imported fertilizers.
Now, what is the name of your technology, and how are you packaging it?
Well, the basic technology is pretty well understood. It's anaerobic digestion. But in general, anaerobic digestion has been used to treat high strength, high solids, rather than low strength wastewaters. And we've been focused primarily not so much on destroying the solids, because there's not so much water in there. Our big interest is actually cleaning up the water so that it can be reused, and reducing the energy involved in both that cleanup and its replacement as well. So if every drop of water, every gallon of water that is recycled is water that you're not pulling out of the ground. So it's a real win-win when you focus on the water aspect.
And where are you applying the technology now?
So we're developing a project in central Oahu where we're putting these practices into practice. So we're installing wastewater treatment at the Kunia village, which is in the very center of Oahu. And we're creating a sustainable agricultural industry based on both the reuse of that water and the creation of renewable energy in the production of it. Sorry.
So this slide here shows the Kunia village. Can you walk us through it?
So in the center you see WWTP, that's wastewater treatment plant. And so you can see that from the farm worker housing, you've got the sewage going to the wastewater treatment plant. The nutrients, including water, are going towards the production of foods and ornamental crops in greenhouses. So what we're doing there is trying to squeeze out every bit of utility from that wastewater. And the wastewater that's been processed in that plant has been disinfected, and it's brought to the highest rating, so it's called R1, and that's allowable by the county of or the state, by the state of Hawaii. And we're also creating energy on the roofs of greenhouses that will be driving the irrigation pumps that supply the water to the farms in the surrounding areas, as well as they provide the drinking water for the farm worker housing and the businesses that are part of the Kunia village.
Well, we're going to take a little break, and when we come back, I want to ask you some more specifics about the Kunia Village project. So
Great.
we'll be right back with Sustainable Hawaii.
Okay, I'm Jay Fidel, that's Ray Starling. We co-host a show called Hawaii, the State of Clean Energy, every Wednesday, 4 to 5 p.m. It's really interesting. You know, Ray has a way of unzipping these guys. He asks them these questions and all this stuff tumbles out, and we find out stuff we would never know about without Ray's questions. Thank you, Ray.
You're welcome, Jay. I'm very pleased to be your Ed McMahon every Wednesday at 4 o'clock here on the internet. So you can join us and see what's happening in the energy world, and there is a lot going on. So join us every Wednesday at 4 o'clock.
Yeah, come around, be energized right here on Think Tech. Aloha.
Aloha, this is Maria Mera, and I'm here to invite you to my bilingual show, Viva Hawaii on Think Tech Hawaii, every other Monday at 3 p.m. We're here to inform, motivate, and entertain you. Join us. Hola, soy María Mera y estoy aquí para invitaros a mi show bilingüe Viva Hawaii en Think Tech Hawaii cada 2 lunes a las 3 de la tarde. Estamos aquí para informaros, motivaros y entreteneros. Apuntaros.
Aloha, we're back with Dennis Furukawa of Real Green Power discussing waste, water, and energy solutions for Hawaii. And we were just walking through that slide, maybe we can look at it again, that shows the Kunia village and the operation. Walk us through Real Green Power's applications there.
So we were mentioning the central role of the water recycling to create irrigation water,
so that's the arrow on the left.
Right. The
left and right, I'm sorry.
Yeah, right. So in the greenhouses, the water that we're providing, we give our farmers the opportunity to use well water that is not recycled, but it costs money. So there's the energy cost and there's the replacement value cost. But what we're offering is recycled water for free, and because it has the nutrients in it, then it will both reduce their cost in terms of, reducing the amount of fertilizer that they need, as well as the direct cost of water.
Oh, that's a very important point. So they're getting the water for free. They're not paying the electricity to pump the water if they were connected in with the city and county water system. And they're getting the nutrients, which means they're not paying for additional fertilizer.
Right.
That's a huge win-win.
There's a hurdle, right, in terms of getting people to accept the use of recycled water. But in fact, right, a lot of people get their drinking water from the Mississippi River, and it's been estimated that by the time you get down to Louisiana, that water has been used 10 or 15 times by other communities. It's been treated, it's been returned back into the Mississippi River.
Interesting.
Yeah, so.
But that's not the case in Hawaii, right? Has it been used several times in Hawaii before it's returned back to the groundwater?
No, it has not. But here in Hawaii, one of the things that is of concern is that we just had the driest January on record. There was like no measurable rain.
And we've had a drought for over 9 years, right?
Well, and this is an El Nino event, which is it's projected that it's going to really put a crimp on the amount of rain that we see over the next few years. So, selfishly, I'd like to see that we draw less from the groundwater, because what's happening is salt water is intruding into our aquifers And we're doing a pretty poor job of actually reducing the amount of water that we're drawing from the aquifers. So.
Interesting. So you mentioned also that you're putting PV on the greenhouses, and I think we have a couple slides of those greenhouses, and you can imagine the size. Is this the PV array, and how much?
Right.
How many
so
kilowatts or megawatts are you producing?
So we're putting in almost 9 acres of structure, and that they have photovoltaics that cover a percentage of that roof. We're at between 2 and 5 megawatts per of production, depending upon how much sunlight is coming out, just on those greenhouses. And there are additional photovoltaic panels that we're sprinkling on roofs throughout the village.
On the residential rooftops?
The business rooftops.
Okay.
And we're also creating some other ground-mounted structures which will provide shelter for chickens and goats. The objective here is actually to take the Cunha village off of the grid entirely. We'll be running irrigation system entirely on renewable power. We'll be providing the major businesses with their power from 100% renewable energy.
How many acres again did you say that the whole Cunha village operation is?
Well, the greenhouses themselves are covering about 8 to 9 acres. The total amount of photovoltaics in there, I'm not exactly sure. We've got a lot of contracts going right now.
But you also have the whole village area, and how many people or farmers are housed there? And so how many potential rooftops are there to extend that PV, or is it needed? Do you provide enough on those arrays for the residential use as well?
Yeah, the number of homes there right now, I believe, are around 150 homes. They're trying to gradually expand the number of homes up to about 250,
Oh,
I
wow.
believe.
Terrific.
But the number of farms that we serve are actually numerous, and they surround the Cunha village. They're not actually within the Cunha village. So the major users of the irrigation water, which we provide the energy to supply, are Monsanto and Syngenta. And then there are a number of private farms. Fat Law is one, and a few other smaller
And are
private
these
farmers.
mostly truck farmers, or is it produce at the farmer's market, or is it larger quantities going to the grocers and wholesale distributors?
It's both. It's both. Yeah, there are a number of smaller truck farmers, which are, I think they're subleasing land.
Mhm.
But I haven't been focused so much on that, and I'm primarily focused on the water within the development of the wastewater treatment and recycling end.
Wonderful. So how is this going to help Hawaii?
Well, we think it's a model that is particularly powerful for island communities. And the state is going to see both a reduction in the amount of energy that is imported, and we believe that the amount of food that is going to be produced through, for instance, hydroponics in greenhouses, it has a massive potential. Greenhouses have an increase in productivity that a lot of people estimate, 5 to 10 times as productive as open land. And it's quite possible to see us make a huge change in the amount of food that we import. And already we're seeing that with lettuce. There are a number of companies that are providing hydroponic lettuce here in Hawaii. And it's really radically reduced the amount of imports. And the restaurants are big customers for the hydroponic produce.
Right, and you even see that now in the farmers markets, and
Absolutely.
I wonder if there's been a study done that shows the replacement of locally produced lettuce and other items that were at one time just the high-end market for the very specific menu items at the higher-end hotels, restaurants in the hotels. And now that seems to be trickling down to the average population that is looking for the same kind of locally produced and specialty grocery product in order to have it in our own homes every week. Do you know if there's any work being done? I know the Department of Agriculture has been super understaffed and having a hard time just collecting raw data that they used to be able to collect. So again, I keep giving opportunities for ideas for PhD candidates to have theses in these areas. So let's look at how much is being displaced by locally produced products in terms of imports, but also how much is the amount of land being required based on these advances and using more sustainable practices being reduced, so that at one time we thought, we needed to have X amount of acres statewide, and you're saying with some of these practices we can actually produce more concentrated amounts on smaller amounts of land and smaller amounts of water and energy?
Well, one of the things that are really illustrative, I think, is how many people are doing aquaponics in their backyards, and and the productivity of these postage stamp systems is quite remarkable. So it's quite possible, I think, for us to reduce our food imports by massive amounts, 60%, if we develop enough diversity in the amount of, or in the things that we produce.
And it comes to mind that Jeff Melrose did do a study like this for the Big Island, and I'm wondering, I think we should find out whether there's one statewide. But we need to take a break, and we'll be right back with Dennis Furukawa discussing wastewater and energy for Hawaii.
Aloha, namaskar, and hello. My name is Anu Hittel, and I host a show, Climate Change Beyond Outrage. In it, we go beyond outrage to look at solutions to climate problems facing people, nations, and the world. Join me every Tuesday at 1 o'clock Hawaii Standard Time. See you then.
Aloha, this is Reg Baker, and I am the host of Business in Hawaii. We talk about positive stories of businesses in Hawaii, how they have been successful, and how they have overcome some of the obstacles that a lot of us encounter when we try to have a business here. And believe it or not, there are a number of positive stories here, and we want to talk to all of you. So we broadcast live every Thursday at 2 o'clock, and it rebroadcasts again on Olelo Channel 54. So I sure hope to see you next time. Please tune in on Thursdays at 2 o'clock. Thank you.
Aloha, we're back with Dennis Furukawa and with Real Green Power, talking about water, waste, and energy solutions for Hawaii. So we were talking about the application of the anaerobic digestion technology for the farms, and we went through that beautiful diagram of Kunia Village and trying to make a more closed loop system that brings down energy costs, water costs, and also contributes to lower fertilizer needs. Where are some of the other applications in Hawaii, and what are some of the other benefits that you haven't mentioned?
Well, I am particularly interested in taking advantage of recycled wastewater for my own farming desires. I'm interested in cacao, growing cacao, and
as opposed to caca. Sorry.
You're
Couldn't
rolling on
resist.
your puns today, yeah. But as a tree crop, or they have no issues in terms of threats to disease or anything like that. There's no direct contact between you know, the water and the fruits. So I'm interested in getting that going. But I think the main thrust is that if you think about that 100 million gallons a day that is being dumped out into the ocean, really, I think it was only maybe a couple million gallons at the most currently are being recycled. And one of the big problems that's keeping that water from being recycled is the location of where the sewage treatment plants are. The sewage treatment plants are right down by the ocean, and then so we've spent all of this infrastructure and energy to get the sewage all the way down to the lowest possible spot on the island, to get that treated water up to where it can be used at a large scale.
Very interesting obstacle.
It's a
So
huge one.
we're using gravity and as little energy as we can to get that kukai treated and put back into the ocean. Now, how are we going to pump it back up with little energy and not a lot of loss of the water, because we know in the piping systems we lose water? Yeah, that's a very interesting obstacle. So what are some of the solutions that you see out there to do that? Or does that mean we're going to have distributed systems and not rely on the large wastewater treatment plants?
I think that's exactly my point, is that if we can install smaller sewage treatment plants at the perimeter of the service area, nearby the opportunities to reuse that water at a large scale and to take advantage of the nutrients in a meaningful way, then we'll have really moved the needle in terms of our reliance on imported fertilizers and our water withdrawals from the aquifers.
Now, is that going to require some significant regulatory changes? Because I'm not familiar with it, but I'm just wondering if you can place wastewater treatment plants in certain residential areas, for example. You know, the zoning laws and then the permitting laws might, have to be looked at in order to be able to do more distributed systems.
Well, interestingly enough, I mean, you threw out that other statistics, which is there's, 90,000 homes
Cesspools
that are not connected to the sewers.
Right.
So the big challenge, I think, there is that we need to get those homes connected to something. And it would be far cheaper to hook them up to a localized wastewater treatment plant and then be able to capitalize on those nutrients and that water.
And I'm sure the average householder and taxpayer would agree with you, particularly when we've seen how expensive it is often to connect into the city and county sewage treatment system. Being a longtime resident of Kailua, I've experienced not only that, but the long years of issues that have resulted and that are constantly working on the roads because of the sewage treatment problem and all of the multiplier effects of having those roads closed and the work being done on them. So that's a good segue into what are the taxpayer benefits. On the technology you're looking at, the anaerobic digestion, are there any tax credits available for investing in them?
There are. Primarily, though, I don't think we need so many of those tax credits. I think that the big cost, which is that needs to be borne, is hooking everything up. So it wouldn't be, I think, a tax credit necessarily going to us. It would be maybe rural development. Has programs that would be there for infrastructure.
Right, and or maybe lowering fees for the hookup and figuring out how to bear the cost across lots of people. Yeah, so there's lots of different conversations we could have about how to finance it.
Yeah.
Yeah. Now, I know that there are some other applications that Real Green Power you've been looking at for these rural users. And we mentioned, the 90,000 cesspools. So, and there's a law apparently in the legislature right now where a lot of people are watching that might finally outlaw cesspools. And I don't know what the status of that is. I think it's still alive. So if they're outlawed, where are people going to turn to be able to make sure that they comply and close their cesspools? Are you offering a solution for that?
We have a couple ideas that, and we've already mentioned one, right? So distributed wastewater treatment plants, so localized, probably in the 100 or a couple hundred houses could be within a service district that would be affordably installed and cheaper to operate for sure than the current technologies. So anaerobic digestion, one of the great values or advantages that it has is it doesn't require an energy input for the biology to work, whereas the traditional methods require the supply, the injection of air into wastewater, and that requires a lot of energy to run blowers under pressure
Right.
in order to get those bubbles to come up underwater. So the other idea that we're working on is that anaerobic digestion can deal with the cesspool, the septic waste that's pumped out of cesspools.
Oh.
So one of the problems is that we have so many cesspools right now that are not functioning very well, and the need to pump those cesspools is great, but they exert a lot of energy demand on the wastewater treatment plants that receive septic waste.
So they're pumped by trucks that arrive, suck it all out. The trucks then have to drive to the wastewater treatment plant, and the treatment plant then has to receive it, has to be pumped back out again. That's a lot of energy, not to mention the transportation cost and the inefficiencies of it.
Well, I'm primarily concerned about the cost that the ratepayers of the sewage treatment plant bears, because it's those ratepayers that have to pay for the energy that that is used to process that sewage. So by using anaerobic digestion as that primary method, it doesn't have an energy, a significant energy demand, and it actually can produce methane from the pumped septage.
Okay.
So the advantages, for the taxpayer is keeping those costs from becoming borne by those ratepayers,
Right.
and avoiding the cost of creating the infrastructure to hook up all of those
Cesspools.
Yeah,
Right.
yeah, to replace all of those cesspools.
So I know that one of the things you've been looking at, not looking at, that you're actually developed, is a modular mobile toilet system that would serve as a cesspool, or sorry, a wastewater treatment, mini wastewater treatment plant in and of itself, and provide all these services on a much smaller scale?
Right, we've been able to build our wastewater treatment system at a variety of scales, from like teeny tiny benchtop to large, industrial-sized units. And so we're putting together systems that are housed within a 20-foot shipping container that both combine toilets and a wastewater treatment plant that recycles the water that is used for flushing the toilets. And so it recycles that water over and over.
And here we have a slide. What are these called?
We call them modular toilet systems, MTS. I'm not that creative, I guess, but the point is that they're designed to be placed where there are no sewer hookups.
So those look like 6 units toilet, bathrooms, right?
6
And then
compartments.
6 compartments.
And they're a little larger than the size of like your aircraft toilet compartments, you know, on a commercial airliner. They have flushing toilets and working sinks. So they're a real step up from a porta potty.
And on the right is the treatment process?
Right, that's the treatment facility. So it is a multiple treatment step operation that both biologically treats to break down the pollutants, and then there are filters and scrubbers that polish the water so that it meets the reuse standards, the highest reuse standards.
And where does the water go?
Well, so the water can be used to flush the toilets over and over, but it also is designed to discharge water that is of irrigation quality.
And it contains those nutrients, the phosphates and nitrogen.
Yes.
That also then eliminates the need to buy more fertilizer.
Right. So
That's tremendous.
Yeah. So our idea is that you can create gardens around the unit, and even create, you know, a green wall that would be cladding the unit. So it makes it softer and more attractive than just a
How
metal
exciting.
shipping container.
Well, in the couple minutes that we have left, tell me where you have these demonstrated and how somebody might be able to get them.
Well, so we're in the middle right now of building a customer list, which will go a long way to helping us produce these things at a scale where they can be affordable. We have the system all in parts right now. Just the wastewater treatment system, which is producing treated wastewater, and we've gone through 3 years of testing with lab analysis on a weekly basis to demonstrate the efficacy of the wastewater treatment plant,
Process,
facility.
yeah.
But we haven't yet actually created the actual combination of the toilet. So right now we're building a list of customers so that it proves to all of the the banks that it's worthwhile spending the money on this.
I see the tremendous application for places like Camp Mokuleia, where my husband runs the camp and is looking for always more sustainable ways to manage the mounds of kukai that thousands of people eliminate every year. Sorry, couldn't help with the puns anymore. But I also see an application for perhaps our homeless issues as we try and develop more cutting-edge solutions to housing for homeless, and particularly if we're looking at temporary housing. What are some of the other applications you see? I guess rural farms, sorry. And as we close, tell me your last thought on where else could this be?
Well, we're targeting situations where there are large groups of users needing sanitation for long periods of time. These are not necessarily appropriate solutions for a concert where you would have just a few days where
Right.
you have a lot of people.
So it's for a rural application with a
Absolutely.
long-term need.
And we are definitely focused on the homeless issue. We're interested in applying them at the beach parks where you have a septic system that is right
Voila.
next to the beach.
Boy, do we need that.
Yes.
Well, Dennis, I'm hearing in my ear that we need to close,
Great.
but we'll have to have you back on to see the progress of this and where else we'll be seeing them pop up around the islands. Thank you for joining us at Sustainable Hawaii. Tune in next week at noon. Aloha.